Welcome to the CODECO's project review video for the second use case, a vehicular digital twin for safe urban mobility. This video pretends to thoroughly explain, both practically and technically, what this use case does, and how it relates to the CODECO framework. First, it's important to clarify concepts and explain exactly what is understood for a vehicular digital twin. The aim of a vehicular digital twin is to monitor and track all moving actors in a mobility environment. 2. Then, use this information to improve efficiency and safety. This use case is focused on the so-called vulnerable road users, which regard mobility actors like pedestrians, bikes or electric scooters. And, uses the digital twin to avoid possible incidents that might lead to the injury of such vulnerable actors. The use case interconnects all actors using V2X technologies or conventional mobile communications, depending on users' characteristics, and gathers each node position thanks to the cloud edge deployment of the digital twins components handled by the CODECO framework. Then, if any anomaly or possible incident is detected, the whole system can notify users with alerts, recommendations or mandatory behaviors. The technologies used to make the use case possible present an inherent challenge that needs to be addressed. Actors interact with each other as using a communications solution whose main pillar is V2X. But the need of specific hardware, and the impossibility for lightweight actors to carry such hardware, forces the usage of conventional mobile communications for such road users. This poses the fundamental challenge of enabling interoperability between both technologies, which is possible thanks to the use case components. This slide depicts how the interoperability plays out, being backed up by the cloud edge continuum. What this use case will demonstrate is the alerting of road users that might be following a problematic path, or having a behavior that might lead to an incident. Let's explain how this will play out. The principal pillar of a vehicular digital twin regards the perfect tracking of all moving actors. In this use case, it is expected from each node to broadcast their sense GNSS position to the other peers through the communications system explained before. This slide shows how different types of actors periodically measure their GPS position and disseminate it. This allows the dynamic map, which is the component that enables the tracking of vehicles in the digital twin, to constantly gather and monitor this information. A collision risk warning application will be constantly monitoring the trajectories of all involved road users thanks to the system explained in the previous slide. Once it detects any possible collision, it will issue a warning that will be geo-broadcasted to the regarded nodes. The geo-broadcasting is direct in the V2X realm, but it will be emulated in the case of 5G, where the messages will be unicasted by routing them to the road users that appear in the regarded area in a geographically scoped routing table. Let's understand the different user journeys. Before further explanation, it's important to remark that VNet stands for Vehicular Ad Hoc Network, and it could be understood as a synonym of V2X. The non-VNet vulnerable road users will use conventional mobile communications to engage in the system. In a nutshell, their story regards being connected to the V2X as a service component, provided in the cloud edge continuum, and run the functionalities explained in the previous slides. Let's understand the different user journeys. Before further explanation, it's important to remark that VNet stands for Vehicular Ad Hoc Network, and it could be understood as a synonym of V2X. The non-VNet vulnerable road users will use conventional mobile communications to engage in the system. In a nutshell, their story regards being connected to the V2X as a service component, provided in the cloud edge continuum, and run the functionalities explained in the previous slides. Let's understand the different user journeys. Before further explanation, it's important to remark that VNet stands for Vehicular Ad Hoc Network, and it could be understood as a synonym of V2X. The non-VNet vulnerable road users will use conventional mobile communications to engage in the system. In a nutshell, their story regards being connected to the V2X as a service component, provided in the cloud edge continuum, and run the functionalities explained in the previous slides. Let's understand the different user journeys. Before further explanation, it's important to remark that VNet stands for Vehicular Ad Hoc Network, and it could be understood as a synonym of V2X. The non-VNet vulnerable road users will use conventional mobile communications to engage in the system. In a nutshell, their story regards being connected to the V2X as a service component, provided in the cloud edge continuum, and run the functionalities explained in the previous slides. The CODECO framework deploys monitors and reschedules all the software components across the cloud edge continuum, and provides a remarkable performance enhancement, thanks to predicting and detecting better deployments, and acting accordingly to this information. This last slide shows an example of multiple scheduled components across multiple nodes in the cloud edge continuum. There can be seen how there is one V2X as a service component providing V2X services to each non-VNet connected user. How messages are forwarded and replied to all neighboring road users in order to simulate a pilot where every mobility actor is using V2X specific hardware. And finally, it can be seen how edges connected to RSUs can parallelly process V2X protocol layers by having different instances of the same component, and, that way be able to enhance latencies. This footage was recorded in a pre-demo carried out at the university campus, next to I2CAT offices. Which is the scenario where the final demo will be done. Starting from showing specific CV2X hardware equipped at a vehicle. This is how the vehicle will show the awareness of all participant users. And if necessary, alert the driver. This is what a vulnerable road user will see at their smartphone when engaging with a possible risky situation. And, finally, there is shown the first version of the UI that the road operator will use to interact with the digital twin.